1. A police academy instructor designs a math module for cadets focusing on patrol shift scheduling using ratios. Which instructional strategy aligns best with adult learning principles? A. Lecture-based delivery without real-world examples. B. Repetitive drills focused on memorization. C. Scenario-based activities involving actual scheduling cases. D. Timed quizzes with no feedback or discussion. 2. A cadet struggles with calculating drug weight conversions during a math assessment. As a mentor, what is the most appropriate action? A. Ignore the issue and proceed with other topics. B. Provide a formula sheet without explanation. C. Guide the cadet using real-world conversion examples. D. Ask the cadet to study independently before seeking help. 3. When developing a test question involving distance speed time calculations for pursuit scenarios, which component is most essential to ensure alignment with high-stakes assessment standards? A. Use of jargon without context. B. Inclusion of complex formulas only. C. Clear, real-life context with measurable outcomes. D. Randomized answer positions. 4. During a math lesson on evidence inventory, a trainer uses abstract algebraic expressions without connecting to actual police procedures. This approach most likely violates which adult learning principle? A. Self-directed learning. B. Relevance to job tasks. C. Peer collaboration. D. Use of technology in instruction. 5. Which of the following is a best practice when evaluating cadet performance on budget allocation problems in police operations? A. Use only multiple choice questions. B. Evaluate using a rubric based on logic and application. C. Grade based solely on speed of response. D. Avoid giving post-assessment feedback. 6. A math curriculum for police recruits includes complex statistical methods without explaining relevance. What curriculum development error is being committed? A. Overloading cognitive memory. B. Ignoring backward design principles. C. Using outdated pedagogical tools. D. Implementing continuous reinforcement. 7. In a unit on calculating perimeters for crime scene mapping, which approach best supports adult learners' motivation? A. Repeating formulas until memorized. B. Incorporating case studies from local investigations. C. Assigning textbook homework. D. Providing no context for formulas. 8. A new instructor is mentoring cadets on fare evasion fine calculations using variable fines by zone. Which mentoring technique aligns with best practices? A. Assigning independent reading only. B. Demonstrating examples and inviting cadets to explain. C. Giving the answers without elaboration. D. Using rote memorization drills. 9. While designing a test on unit rate problems e.g., cost per unit for equipment, which guideline supports regulatory compliance and law enforcement education? A. Avoiding scenarios involving fiscal decisions. B. Ensuring questions reflect job-relevant decisions. C. Focusing only on theoretical math. D. Using non-contextual numerical patterns. 10. A cadet performs poorly on percentage decrease questions related to crime reduction. What instructional intervention supports adult learning and retention? A. Reteaching with different crime trend examples. B. Asking the cadet to write the formulas 10 times. C. Skipping the topic in future lessons. D. Scheduling more tests without remediation. 11. A police math test includes questions on time card analysis. What is the most effective way to align test content with workplace application? A. Use time card formats identical to department systems. B. Use generic time-related math problems. C. Focus on analog clock arithmetic only. D. Avoid any context in question stems. 12. What is the most effective mentoring technique for supporting a cadet struggling with determining the probability of multiple incident outcomes? A. Assigning peer tutors to explain concepts. B. Ignoring the errors to build confidence. C. Encouraging guesswork under pressure. D. Focusing exclusively on definitions. 13. A training officer evaluates recruits on ratio and proportion problems related to patrol coverage. Which of the following provides the most valid measure? A. Scenario-based math problems mimicking dispatch allocation. B. Timed drills on abstract ratio problems. C. Open book quizzes without context. D. Matching terms with definitions. 14. When designing curriculum for police math training, which method ensures alignment with backward design? A. Starting with final outcomes like call-response calculations. B. Designing lessons based on available worksheets. C. Focusing first on textbook chapter outlines. D. Planning for entertainment value. 15. A training manager must ensure that a math skills exam used for promotion aligns with compliance guidelines. What should be the priority? A. Incorporate only generic math unrelated to job roles. B. Ensure tasks reflect actual supervisory responsibilities. C. Test only historical math concepts. D. Use identical questions from past assessments. 16. A lesson on fine calculations shows diverse cadet performance. What evaluation method supports formative assessment? A. A reflective journal discussing fine-related decisions. B. A high-stakes final exam. C. A group debate on the history of fines. D. A written policy summary. 17. In a peer mentoring context, how can advanced cadets assist struggling peers in solving area problems related to accident diagrams? A. Offer guided walkthroughs using sketch tools. B. Only offer formula sheets. C. Quiz them on unrelated math facts. D. Refer them to online math games. 18. Which approach best ensures high cognitive engagement in a training session on budget forecasting? A. Interactive simulations using department budget templates. B. Solving generic word problems. C. Copying tables from textbooks. D. Watching an unrelated math documentary. 19. A police trainer wants to improve communication of mathematical concepts during roll call briefings. What is the most effective method? A. Use visual aids like graphs and charts. B. Recite formulas from memory. C. Avoid presenting numbers to reduce confusion. D. Delegate math explanation to cadets only. 20. A curriculum reviewer notices no performance tasks on mileage reimbursement calculations in the final exam. What principle is being overlooked? A. Validity through alignment with real-world application. B. Use of purely visual teaching methods. C. Avoidance of peer-led instruction. D. Emphasis on summative feedback only. Police math tests. Police math tests are specialized assessments designed to evaluate the mathematical skills essential for law enforcement duties. These tests measure a candidate's ability to perform calculations related to patrol scheduling, crime statistics, budgeting, time-distance analysis, and report accuracy. Often administered as part of police entrance exams or ongoing professional training, the tests emphasize real-world problem-solving using arithmetic, percentages, ratios, algebra, and data interpretation. Police officers must apply math in high-pressure situations, such as estimating crime scene dimensions or calculating evidence quantities. Therefore, police math tests ensure that individuals are prepared to think critically, make accurate decisions, and maintain operational efficiency in the field. Here are the top 5 beneficial uses of the police math exam. 1. Operational decision-making. Police math tests help ensure that officers can accurately interpret numerical data for resource allocation, patrol planning, and crime analysis, supporting informed, data-driven decisions. 2. Evidence documentation accuracy. Officers often deal with measurements, weights, and time calculations. Math proficiency ensures precise documentation and reporting, critical in investigations and court proceedings. 3. Budget and resource management. Law enforcement personnel must understand financial concepts such as overtime pay, supply costs, and budget forecasts. Math tests prepare them to manage resources efficiently and comply with fiscal policies. 4. Enhancing public safety efficiency. Accurate math application in tasks like pursuit timing and incident response improves service delivery and safety outcomes. 5. Supporting career development. Strong performance in math tests can be crucial for promotions, specialized units, and leadership roles where analytical and quantitative skills are vital.